Okay, here we go. So this is just a little reminder of what we did yesterday. You've got the red one is the parent function, and it's y equals 3 to the x. And you've got it. Normally we'd use y equals 2 to the x, but now we got the green one. Does it appear to you that it's moved upwards? Okay. The question is did it move up or did it stretch up? It moved up how far? Because the reason you can tell it's not a stretch is that this from 1 to 3 is 2. And this from 3 to 5 is 2. And so it stayed the same. If it's really a stretch, it'll be more like this. If it goes from 1 to 3 and it was a stretch, how do you get from 1 to 3? You times by 3. And how do I get from, well, I'd have 3 would go all the way up to what? 9. It should be actually way up here. So that's what a stretch would have looked like, would have been where this point goes up times 3 and this point also goes up times 3. All right, so bottom line is we now know that it is y equals 3 to the x, but then I have to somehow signify that it moved up 2. Where do I put that 2? On the outside. That's up 2. What if I'd have put it here? What would that mean? That'd have been left 2. Okay. Okay, moving on. Just gloss over the homework slides we did. This is a great big list of all of the properties. We're going to go through them one at a time. You have to know every property of exponents because why? What are we studying right now? Properties of exponents is the title for the day, but generally the unit is called exponentials. And finish this sentence. Exponentials have a x in the exponent. Okay, so if you see an equation that you're not sure exactly what to do with, at least you'd know what it is right now. If it's got an x in the exponent, that's an exponential. All right, now here are some of the properties, and I'd like you to write these down in any way that you'd like to take notes, but that does involve taking the notes. So here's the first one. It's the product property. Basically, that means when you're multiplying them. Could I just keep it as simple as saying you just add the exponents? Sure, I could do that. And that's true. It's just going to be 3 to the 7th. But I need you to understand why. Why does it work that way? Because you're going to forget whether you should multiply them or add them or what you should do to them. And so we need to have a basis for why this works. So I'm going to break it down into its parts. 3 to the 4th means 3 times 3 times 3 times 3. Would you agree with that? And 3 to the 3rd means 3 times 3 times 3. And this was a times problem, so I can put a times in between them. Can you see why it's 3 to the 7th? You've got a whole bunch of 3s. 1, 2, 3, 4, 5, 6, 7 3s, so 3 to the 7th. It makes sense. So if I was going to do this with variables, it would be a to the what? M plus n. All right, good. Come on to the next one. This kind, it's a power to a power. Do I multiply them? Do I add them? What do you think? Multiply them. And so the answer is 3 to the 6th. But again, I don't want you to just know that, okay, it's multiplied, but I'm going to memorize that for the rest of my life. I want you to be able to back it up and say, how could I get that to work without even knowing what to do? That just have to multiply them. Explode the problem into its parts, one little piece at a time. What is 3 to the 2nd the same as? 3 times 3 to the 3rd. See what I did there? Just broke it up in its parts. And now, to the 3rd means that I have 3 of them, all multiplied, right? 3 to the 3rd, or sorry, 3 times 3 and 3 times 3 and 3 times 3. And these are all multiplied. How many 3's are there? 3 to the 6th. And you can figure out for yourself if you get stuck and you can't remember if you should add them or multiply them. This will remind you. So it's multiply them. So this is the Minnesota property. Why? A to the mn. There you go. Okay, on to quotient property. That means I'm dividing a couple things, and they have powers in them. This only works if the bases are the same. So for instance, here I've got a 2 as my base. And then what do you think I do to the 5 and the 2? Subtract them. So I do 5 minus 2 is 3, so it's 2 to the 3rd. And that is correct. You just subtract them. But I want you to have a basis for this. So explode this out. And this one I want you to write down on your paper. Write out what that means on the top and what that means on the bottom. Write it down. This is laying a foundation for tomorrow where we're going to do a lot of canceling. So what's on top? What's on the bottom? And as soon as you see that, I want you to think, oh, canceling. You should notice that. Okay, and that leaves what left? 2 times 2 times 2, which is 2 to the third. And yes, that does mean you just subtract these two. All right, even when it gets weird like this, a to the 8th over a to the negative third, you subtract them. You don't go 8 minus 3 makes 5. You go 8 minus negative 3. See what I'm saying? This minus that. Nope. So final answer for this one would be a to the 8 minus negative 3, which means that's the same as 8 plus 3, so it's a to the 11th. All right, and somebody's mentioning that those negative, that a to the negative third kind of wants to go on top. I agree. Let me show you why. A to the 8th is a, all over. A to the negative third, those are saying that they're not happy on the bottom and they want to come up to the top. That's 1 over a to the third is really what it is. But whenever you have a fraction in a fraction, you can use this and say, okay, these negatives want to go up to the top, and those a's that were going to be on the bottom are going to go on to the top. And then I end up adding up the 8 plus the 3 makes a to the 11th. So you're kind of right, but the final answer still comes out to a to the 11th. Good. Okay. We're going to talk more about that tomorrow. All right, on to this one. Negative exponents. This is really, really crucial. Pay attention. There's 2 parts to this class, this lesson that are crucial, and this is one of them. Okay. If I take 2 to the negative second power, math, there's a lot of math has to do with substitution. I'm going to just substitute this for this, which is going to mean the same thing. Would you agree that if I multiply out what I wrote in red there, that I get 2 to the negative second? You get that? Now, why did I break it up like that? Because you know how to do 2 to the second. What is 2 to the second? 4. And so this is really, I'm using substitution again, 4 to the negative 1. And then really all you got to know what to do is whenever there's anything to the negative 1 power, you use the reciprocal of it. So the final answer is, instead of 4, it is 1/4. So if you did this on your calculator, it would tell you the answer is 0.25 because it's 1/4. All right. I know some of you were following me on that and some of you weren't. I'm going to just do a quick test check here. What's 7 to the negative 1? 1/7. Anything to the negative 1 power is just flip it. Okay? What's 2/3 to the negative 1 power? 3/2. You just flip it. This one was 1/7. How about this? 7 to the negative 2 power. Well, then I do 2 parts. I got to do 7 to the second and then the negative 1. What's 7 to the second? And then the negative 1 power does what? 1/49. You get that? That's what negative exponents do. Negative exponents, one of the common misconceptions is that they make the answer negative. They don't. All they do is they make it flip. They make it a reciprocal of itself. All right, so on your paper, try this one. Just write your answer out. We'll see if you really get it. Raise your hand when you're done. Good. In the back row. You are so right. Raise your hand if you had it right. Good. On to the next topic. 0 exponents. This is the easiest of them all. 1. Anything to the 0 power is 1. So, what's this? Yes. 1. Anything to 0 power. Okay. So just all you got to do is remember that. Now, one thing, a lot of people say, but that just doesn't seem right. Because like 3 to the third I should probably do this on the second part of my video, so I'm going to hold that thought.